Hello guys, today I'm just making a quick video for A-level chemistry with the concept empirical and molecular formula. I know many of you guys have this concept coming up for your A-level chemistry exams, so hopefully this video has helped you all to understand this concept much more better through a question practice. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's start with the video. Alright, so the question's asking us, a compound which contains carbon, chlorine, and fluorine only has a relative molecular mass, which is the MR in this case, of 204.0. The elemental analysis shows that the compound contained 69.6% chlorine and 18.6% fluorine by mass. Calculate the molecular formula of this compound. Now, this question has a lot to take in. It's about 4 marks. However, it's combining the concepts of empirical formula, moles, and molecular formula. So it's like a really good question to practice all 3 of them together. So what I would like to do first is to write down the formula to calculate the number of moles. Now I like to use a formula triangle in this case. So we're just going to draw a nice little formula triangle. So on top it's going to be the mass, and at the bottom it's going to be the number of moles, and here it's going to be the MR slash the AR. It depends on the element or the compound in this case. Alright, okay. So the next step is to create like a nice little table that separates carbon, chlorine, and fluorine, since these are the elements in the question. So what I'm going to show you guys here is you're going to write carbon here. You're just going to write carbon, or you could just write their elemental symbols. That's fine as well. You can write chlorine, and you can write fluorine. Okay, fluorine, yeah, the spelling. Okay, so now we have written down our elements. Now the first thing is to analyze what the question has given us, the values they have given us. So they have given us the relative molecular mass of the compound, which is 204.0. So we know that, and we know that they have given us that chlorine has 69.6%, that the compound contains 69.6% of chlorine. So we're going to write that down first, 69.6% of chlorine, and we know there's 18.6% of fluorine. So I'm going to write it down, 18.6% of fluorine. Now, how do we find out what percentage does the compound contain of carbon? So in order to do that, we have to just add these 2 values together and subtract that from 100%. So I'm just going to write it down here. So it's going to be 100% minus these 2 values combined together. So that's going to become 69.6% plus 18.6%. Now you don't need to put the percentage values in your question. You can just leave it as it is in terms of numbers. You can just do 100 minus 69.6 plus 18.6. Now this is going to give you a value of about 11.8%. So we have found out the percentage that the compound contains of carbon is supposed to be 11.8%. So we now have the values in terms of percentages. Now the next thing that we have to calculate is the empirical formula. Now in order to calculate the empirical formula, we need to, what I'm going to do is I'm just going to split this into a table so we can see it much more clearly. Yeah, okay. So the thing we have to do next is to calculate the empirical formula, like I said. So in order to do that, we have to calculate the number of moles first. So we know that the formula for moles is that the number of moles is equivalent to mass divided by the MR or AR. So in this case, we're just going to take the AR, since these are elements, right? It's carbon, chlorine, and fluorine. If they are compounds, take the MR, okay? It's very important that you understand the difference between these two. So it's going to be AR slash MR. So the number of moles of carbon, so it's going to be number of moles, is equivalent to the mass, which is 11.8%. You're just going to take it as 11.8 divided by, now this is the AR. So we know that the AR of carbon in the periodic table is 12. Okay, if you look at the periodic table, you guys can just search it up. The AR of carbon, let's say the relative atomic mass of carbon, is 12. So we're going to divide that by 12, and we're going to get 11.8 divided by 12 to give us about 0.983 moles. Now chlorine, we have to do the same process again. The number of moles is equivalent to 69.6 divided by the AR of chlorine, again, is 35.5. Take the exact values. It's very important that you guys take the exact values. So that's going to give us 1.9605 moles. Then the next step is to calculate the number of moles of fluorine, which in this case is going to become 18.6 divided by the AR of fluorine is I think 19.0. Yeah, 19.0, which is going to give us 0.9789 moles. Now I would like you guys to give your decimal values up to 4 decimal places. That's advisable. Just take as many decimal places as you guys can. It'll give you a more accurate value. Now once we have found out the number of moles of each element, what we're going to do is we're going to divide them by the smallest value among this whole group. We're going to divide them by the smallest number of moles. The reason we're doing this is to get whole numbers. Since empirical formula is the simplest whole number ratio, so we have to get whole numbers. So like at looking at these three values, can you tell me which one has the lowest number of moles, or let's say which is the smallest among all three of them? Among all three of them, it is fluorine. So we can see that the number of moles of fluorine seems to be smallest since chlorine has the greatest number of moles. So that means we're going to divide all of these values by the smallest number of moles. So what I mean by is going to divide everything by the smallest number of moles, which in this case is fluorine. So it's going to become 0.9789. We're going to divide it all by the smallest number of moles, 0.9789. Once you do that, you're going to start getting whole numbers. So here, if I use my calculator and you do 0.983 divided by 0.9789, you're going to get a value of about 1.004, which, if we round it off, is going to become 1. That's a whole number in that case. And if I do for chlorine, 1.9605 divided by 0.9789, you're going to get 2.002, which again is rounded off to 2. And if you do the other way, for fluorine, it's going to become 0.9789 divided by 0.9789. That's just going to give you 1. All right. So these are your whole numbers. Now all we need to do is just start from carbon, since that's how the order is going, from carbon to chlorine and to fluorine. So we're going to start with writing down what's carbon. So this is going to be the empirical formula. This is a very important step. So this is the empirical formula. We're going to find out the empirical formula first in order to find out the molecular formula of the compound. So the empirical formula is going to become carbon 1, chlorine 2, and fluorine 1, which is going to be summarized into carbon, chlorine 2, and fluorine. This is going to be your empirical formula. Okay? That's going to be your empirical formula. If you guys want to take any notes, you guys can take notes. CCl2F. Alright? Now the next step is to find the molecular formula. Now the molecular formula is a bit of an interesting concept, is where we have to find a specific number. Now in order to find out that number, we need to divide, let's say, the molecular mass divided by the relative formula mass of the empirical formula to get a specific number, and we multiply that number by all the elements here to get the molecular formula. So what I mean by this is that first let's find out the MR of CCl2F. This is going to give us carbon, which is 12.0, plus, since there are 2 chlorines, we're going to do 2 times chlorine's AR, which is 35.5, plus the AR of fluorine, which is 19.0. AR just means relative atomic mass, okay, which is going to become equivalent to 102. This is the MR of the empirical formula, which is to be 102. Now once you do that, we are going to, in order to find out that specific number, which we have to multiply by all the values here, we're going to do 204.0. That's given us here in this value here. So we're going to do that 204.0. Usually they will give you that value divided by the MR of our empirical formula, which is 102. This is going to give us approximately a number of a positive 2. Now this is the number which you're going to multiply here each value. So what I mean by that is I'm going to show you. So we have CCl2F. It's going to become, let's say, equals to C1 times 2, Cl2 times 2, fluorine 1 times 2. It's just going to become like this. Once you do that, you're going to get C2, Cl4, F2. Now this is going to be your molecular formula. Now how do you make molecular formula into empirical formula? Just divide it by the smallest number value. In this case, if you divide it all by 2, you're most likely going to get it back to the empirical formula. So that's just to confirm whether our answer is right. So just going to write it nicely here. Yeah, so this is going to be your molecular formula. Your molecular formula is going to become C2 Cl4 F2. This is going to be your answer for this question. So this question, it required the concepts of moles, empirical formula, finding out the number of moles as well, then finding out the MR, relative atomic mass, knowing the relative formula masses, and using that value to calculate a specific number, in this case, to find out the molecular formula. I'm just going to zoom out here so that you guys can take any notes if you guys want to see it. And this is the correct answer. Okay, this seems to be the end of the video. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video. And new content will be posted soon. And yeah, I think that's it. Alright, bye guys.